Hello students, let us continue with the second part of serial port programming of microcontroller 8051. So we have seen the comparison of serial and parallel communication. We have seen some fundamentals of serial communication like how it works, how it is requiring parallel to serial and serial to parallel conversion there. Then the types of or the methods of serial communication, synchronous and asynchronous. In case of 8051, we are specifically using asynchronous serial communication. It consisting of UART. Then the types of serial communications are there: simplex, half duplex, and full duplex. We have seen. Then we have started with asynchronous serial communication. The framing used in asynchronous communication we have studied there. Start bit, LSB of the data, continuing with MSB of the data, and then stop bit. So we have seen the complete framing of the uh, asynchronous serial communication present in 8051 we have seen. Then the data transfer rate, BPS, bits per second, or baud rate. The next one we have seen is RS-232 standard. This is another voltage level present universally for the serial communication. And then for the RS2, along with RS-232 communication, we are having the connectors present there, DB25 and DB9. Then we are having the IC MAX 232 and we are having null modem connection. TXD is connected with RXD and RXD is connected with TXD. Max 232 IC is a voltage converter IC. It will convert TTL to the RS-232 voltage levels and vice versa. Extension of RS-232 IC Max 232 is Max 233. This is a more sophisticated IC than Max 232. Then we have seen the typical baud rates there and how these baud rates are generated in using the 8051 we have seen there. So its basic frequency is 11.0592 megahertz. It is converted to the machine cycle frequency of 921.6 kilohertz. Then further it is divided by 32 to get 28800 hertz, which is given to the timer 1. And from timer 1, by varying the TH1 value, we can generate different baud rates like 9600, 4800, 2400 and 1200. Four baud rates we have seen there. Okay, these are the calculations of baud rates we have seen. So let us start with the next part of the serial communication. For this communication we are using a special register present in UART. This register is called as SBUF. SBUF is nothing but serial buffer register. What is the purpose of this register SBUF? So as its name implies, buffer is something which is used to store. Okay, so for holding the data byte, we are using this buffer register. Whatever the data we want to send over the serial communication, that is TXD line, it is put in the serial buffer, or the data which is received by the RxD line, that is kept in SBUF register. Okay, so we can access the SBUF register by various ways. We can send the data to the SBUF. Okay, like we can send the actual ASCII code. So remember, when you are sending the data on the serial line, we are again using one standard type of the coding there, and that coding is ASCII coding. So you are familiar with ASCII coding in C programming. Whenever you are sending the data in C programming, it is always present in the ASCII code. Similarly, in case of serial communication for 8051, we are using the ASCII codes. So when you send a character or number, its actual ASCII code is sent there. So here we are sending it in the buffer register, SBUF. Okay. Next, you can give the data to the SBUF when you want to transmit it, or you can take the data from the SBUF into the accumulator when you want to receive the data. Okay, so this is the way you are actually transmitting the data with serial communication. When a byte is written in SBUF, it is framed with the start bit and stop bit and transferred serially via the TXD pin. So as soon as you execute this instruction, move SBUF, after the execution of this instruction, it will perform its own job itself. The programmer doesn't have to take care of anything. Whatever we have discussed earlier, everything will be done by the UART module, and it will transfer the data serially via the TXT pin. When the bits are received serially, it will deframe it by eliminating the start and stop bits, and the data byte is placed in the SBUF. So SBUF is very important when transmitting and receiving the data serially. Okay, so we have seen the first register as SBUF. Then the second register is SCON, Serial Control Register. This is also a very important register in case of serial communication of 8051 microcontroller. So the bits of the SCON register are given as in this slide. So the first bit is SM0. We will start with the LSB. First is RI, receive interrupt flag. This is set by hardware halfway through the stop bit in mode 1. Okay, and it must be cleared by the software. So when you are receiving the data, this flag is used. RI is set means your reception is complete. 1 byte is received. Similarly, there is TI, transmit interrupt. So when the transmission is completed, this byte will be 1. Okay, so when 1 byte is transmitted, TI will set. When 1 byte is received, RI will be set. Next, RB8. RB8 and TB8 is used in some spatial communication where you are requiring the 9 bit. Okay, so don't worry about it. We are not going to use it anywhere. We are interested in TI and RI. These are important bits. Next, receiver enable. It is set or cleared by software to enable or disable reception. This should be always 1. Okay, for either reception or transmission, you have to make this bit 1. REN. Then the next one is SM0, SM1 and SM2. So out of that, SM0 and SM1 will use serial port mode specifier. So there are different modes available in serial communication. Okay, so these modes we will discuss afterwards. So these modes are set by SM0 and SM1, and SM2 is used for multiprocessor communication. Just remember it, for multiprocessor communication you have to make it by default 0. So this should be always by default 0, and this should be always by default 1. So remember, these things you have to keep it in mind. TB8 is 0, RB8 is 0. So this is fixed for the serial communication. Okay, we are talking about the SCON, Serial Control Register. Okay, so these are, I will repeat the bits there. Receive interrupt, transmit interrupt, RB8, TB8, receive by bit 8, transmit bit 8, receiver enable, serial mode 2, mode 1 and mode 0 bits. These are used for multiprocessor communication and serial port mode specifier. Next, SM0 and SM1 determines the mode. Only mode 1 is important. When mode 1 is chosen, data frame is okay. So we are talking about SM0 and SM1 bits. These bits are 0, 1. Okay, so when you are having the bits 0, 1, then when mode 1 is chosen, okay, then for this board, the data framing is 8 bit, 1 stop bit and 1 start bit is there. You have to just remember that the combination is 0, 1, and when 0, 1 combination is there, data framing is 8 bit, stop bit is 1 and start bit is 1, and it is compatible with the COM port of PCs. Mode 1 allows baud rate to be variable and is set by the timer 1 of the 8051. For each character, a total of 10 bits are transferred. First is the start bit, followed by 8 bits of data, and finally 1 stop bit. You have seen here. Yeah, here. This is 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. It is transferring 10 bits at a time. Okay, means 10 bits serially one by one transmitted there. Okay, baud rate is set by mode 1 will have a variable baud rate decided by timer 1. So 8 bit, 1 stop bit, 1 start bit. That is fixed for serial communication in mode 1. We are concerned only about the mode 1. We will not bother about any other modes there. Okay. Receiver enable. REN is equal to 1 allows the 8051 to receive the data on TXD. For both transfer and transmitting and receiving the data, REN must be 1. Then TI, when 8051 finishes the transfer of the 8-bit character, it will raise the TI flag to indicate that it is ready to transfer another byte. So we have seen the transmit interrupt and receive interrupt flag. It is indicating to the CPU that uh, UART module has completed its data transmission and reception there. So for that TI and RI flags are used. Then the programming. 8051 programming. So after we have seen the two registers there. One is SBUF, serial buffer register, where you are storing the character, and the second one is SCON register, serial control register, where you are having different flags there. TI, RI, REN, mode register, mode bits, SM0, SM1. All these are present in SCON register. Okay. So with that, we will go through the procedure for serial programming in 8051. Okay. So the first program is, it is a program to transfer the data serially. Okay. So the first part is you have to initialize the TMOD register. Okay. TMOD register, why you need? Because we are requiring timer 1. Okay, am I right? Timer 1 is used to set the baud rate. So, in which mode timer 1 is used? Timer 1 is used in mode 1. Mode 1 is used and therefore it is 0001. Okay. So, you are 0010. Sorry, mode 2. 8-bit auto reload mode. It is having mode 2 8-bit auto reload, and for that you are loading the value 20 in TMOD register. Okay, then TH1 is loaded with the value to set the baud rate. So if you want 9600, it is -3. Then it is 4800, that is -6, and like that. Then the next one is SCON. SCON register is loaded with the value 50H. Okay, so that will set the mode 1 for the serial communication, and it will clear the other flags. Then the next step is TR1. TR1 is set to 1, that is means starting the timer, so it will start generating the timer baud rate frequency. Then TI is cleared by clear TI instruction. Then transmit the character byte which is written into the SBUF register. So you have to put the character to be transmitted in the SBUF register, and then you are waiting for the TI flag to be monitored until the transmission is not completed. When the transmission is completed, TI flag will be 1. Okay. So for the same thing, the program is written here. Move TMOD 20H. So it will set the timer 1. Move TH1 -6. Baud rate is 4800. If you want to set it for 9600, you have to set it as -3. Then move SCON #50. So it will set the mode 1 for the serial communication, 8-bit, 1 stop bit, 1 start bit, and receiver enable. So this is done. And then start the timer, set bit ER1, and then load the character in buffer register SBUF #A, and then the contents of the buffer are transferred serially bit by bit. So once it is completed, it will set the TI flag. So what we will do here is we are waiting for the TI bit to be 1. If it is JNB means jump if not bit. Until the TI bit is not set, we will continue here only. So that is wait for last bit. And after that clear TI. Clear TI means you are clearing the transmit interrupt flag, and as jump to repeat. Repeat means it will once again send the same character, or you can change the character. So this is the program for serial transmission in assembly language. You can load this program and you can observe its output in the Protis window. I will show you that afterwards. Next, importance of the TI flag. If it is used to check if the transfer is completed or not, and TI flag is bit is raised by the program by the 8051 after the completion of the data transfer, and it is cleared by the programmer. Okay. Next, for serially receiving the data. Many things are same there. For the initialization of the data transmission, TMOD register is loaded with the value of 20. TH1 is loaded with the baud rate value. SCON register is loaded with the value of 50H. Then timer 1 is started. RI is cleared. And now instead of waiting for TI, we will wait for RI flag to be set. Once RI is 1, then you can read the value of SBUF. Okay, so reading the value of SBUF is done in serial reception there. Okay, so the program is like this. These steps are same as your transmission. Initialization of TMOD 20, TH1 -6 for baud rate 4800, SCON is 50, and then set TR1, initialize, start the timer, wait for transmission. Sorry, this should be RI. JNB RI here. Once RI is set, take the data from SBUF to the accumulator, clear RI, and wait. Continue. Okay. So instead of TI, here we are using the RI, receive interrupt, for receiving the data serially there, and after that we are copying the contents of SBUF to the accumulator. So for that we are using it. Okay. Now how to change the baud rate? For changing the baud rate, you can use a small bit which is present in PCON register. Okay, so remember, here you can use either a high frequency crystal to change the frequency, or you can change the bit in the PCON register. Okay, so that TMOD SMOD bit will double the baud rate. It will change the baud rate, or it will increase the baud rate by double value. So for that, just this is one addition there for doubling the baud rate in 8051 microcontroller. Okay, so this completes all the discussion about the serial port programming for the 8051 microcontroller. I will just add one more thing related to that. I will show you the demonstration of the actually how the data is transmitted or received serially on the Protis afterwards. Okay. So thank you students. We will stop here.